In this lecture I want to talk about declaring function pointer type aliases. Function pointer type aliases can save you some time because you don't have to type out the entire type. Personally, I prefer to see the entire type, especially as a formal parameter, so I know what argument I should be passing in. Otherwise you have to go and look at what the alias represents, which can also be time consuming. So it depends on your personal preference. So for this example I have these two functions here, add and multiply. We've used these before, and then in the main function I declare this function pointer fptr, which I initialize to multiply. I do a check to see if something exists for that function pointer, so it's not null. I do console output, I invoke the function indirectly, in this case multiply, passing these two arguments 5 and 5, and if I build a run we should get 25 of course. That is going to return the product of 5 and 5. So let's go and create an alias now. We'll start with type definitions. This is how you would create a type alias for a function pointer. Okay, we do type def, we have the type name right here, and this is a pointer to a function with these types for the formal parameters, and that int right here there as a return type. And now we can go and use that in place of this. This alias is a bit long, you might want to shorten that, but this is just for demonstration purposes. Okay, so what we have here is the math operation, that is the alias for the particular type. The type of the function pointer, and then the actual function pointer itself is now OP here for operation. So again we check if the function pointer is null pointer. If not, then we go and indirectly invoke the function that we are pointing at, in this case multiply. Otherwise we print out null pointer. Build and run that. That works fine, we get 25 printed out as before. You can see this is difficult to read, so instead of doing the type definition you can use a type alias. Which will look like this. We have the using keyword, we have the math operation. This is the alias for this type, so we assign this type to this to the left here, so this is easy to read. We can clearly see the alias identifier and the type, which again is here to the right. And this will work fine as well. Build around that. And you can see that works fine. And of course we can go and change what we initialize the function pointer to, such as add. And now we will indirectly invoke the add function through the function pointer right here. That will now print out 10, build and run, and we get 10. And of course we can use the aliases in function formal parameter list as well, as we'll see in upcoming examples. We can also have template type aliases, and to demonstrate that I have a simple example here. I have a less than and a greater than a template function. Both of those have the same signature and return type. Okay, they return bool, and they take in this particular type a reference to tconst. They're going to take in the two operands and do the comparison. So if it is less than, it's going to return true, otherwise false, and the greater than is going to return true, if greater than, otherwise false. Then I have the template type alias right here. I'm doing using test. Using test, I'll just call this test. We have the template here, type name t. Again, the type here needs to match with these two functions up here. And before moving on, I'd like to mention that this here is going to be illegal, so I'll just comment this out to show you. We cannot use type def to create a template type alias. For example, if I try and build this now, we will get an error. A type def template is illegal, so I'll just comment that out again. But okay, we have this template type definition right here called test. That is an alias for this type right here, a templated type. Now we want to go and use that, so I have another function here, compare. Just a simple example here. Of course you can do different things with this. This is also a template. I have type name t right here. The operands is also going to take in operands, and then we do the test. I pass in t here for the type. Of course we want the types to match because that is what we have with the functions and with the templated type. For that formal parameter, instead of using this long type as we have it here, we simply use test and we pass in t, and then we call that comparator, and we can pass in the operands, and then we can return true, or I should say print out true, otherwise we print out false, based on whether or not this is going to return true or false. Again, test is an alias for a function pointer, so this right here is an indirect invocation of a particular function that we will specify where we call it. So here, for example, I pass in greater than, or I pass in less than. So in the main function I have these statements. Again, just as a simple example, I do console output, x is greater than y, and then I do the comparison. X is less than y, and we do the comparison. So I have these two random integers here, just pass in those values, 5 and 27 for example. Of course you can do input, so you can ask the user for input, but I'll just keep it simple for now. And I'll build around that so we can see what we get. 5 is greater than 27, that is false. 5 is less than 27, that is true. Now I might be thinking this is an overcomplicated way of testing, but in this case we are applying it to simple types that we pass in. You can also apply that on a different function that operates maybe on a container that compares all of the elements in a container and returns the greatest or the smallest element within the container, or that will test for and remove duplicate entries where you have two elements that are equal, and so on. And of course you have to keep in mind that these will now work with these operators. So if you want to pass in a user-defined type, class or struct, then you need to make sure to overload those properly for those classes. But other than that, this is really handy if you want to do different types of operations on containers. We'll learn more about different types of containers such as the vector in future lessons, but I just wanted to show you some of the more complex syntax that you might see, and the fact that we can also have templated type aliases, as we can see here. One more example to show you what I mean. I'm still using the less than and the greater than template functions, and then I also have again the template function pointer type alias called test. But in this example I'm using a getElement template function. The first parameter is going to be an array of type t. To const, we're not going to make changes to the array. GetElement accepts an array, it accepts the size of the array, and then we use this templated function pointer type alias, we pass in t. I'll call that comparator here. Then I declare a temporary variable called element that is going to be of type t, and I initialize that to the first element in the array. Then I go and loop through the elements of the array. I'm going to invoke the function indirectly. Okay, you can see right here we pass in those two elements. So we're either going to do greater than or less than. And based on the result, I'm going to assign the element to the temporary variable, which we will eventually return. With this, we have a generalized function that can return, let's say, the greatest or the smallest element within an array. And of course, you can do a similar thing for other containers that you might learn about in future lessons. So in the main function, again, I have the array size, which I set to 3 here just so that we don't have elements initialized to 0. And then I have the victory points array again. I pass in array size, and then I pass in these 3 elements for the construction. That is for the initialization of the elements in the array. And then this is where I actually go and use that getElements function. Pass in the array victory points. We pass in the size of the array for the function, and then we also pass in the particular operation that we want to perform, or the particular comparison that we want to do on each element. So in this case, greater than. This should return the greatest element within the array. Build around that. See, we get 5. Similarly, if I do less than and build around that, we should get 1. Of course, you should test to change those out, swap those around and so on to make sure, test that. And also maybe changing some of the values, such as I will change the second element to 0 and build a run again. Now we get 0, that is the smallest number. And so on, so you can test for greater again, and of course you can experiment with other comparisons as well. But this was a simple example just to show you that this is really handy for writing operations on containers or data structures. Okay, so that is going to wrap up this example and this lecture. I hope you found it interesting.